Alright guys, so this video is on proportion and probability. It's meant to be a supplement to your guys' lecture or after reading your book. Let's do a couple proportions. Alright, so I'm going to go off of this worksheet. So what's the proportion or probability of getting a Z-score greater than 0.25? Okay? So when I first started doing these, I always drew a normal curve. Okay? It just helps me visualize things. So this is a normal curve. Okay? The whole area here, all this is 100%. Okay? So 0, here's, oh, I'm sorry. This is 0 here. This will be 1, maybe -1, 2, 2, -2. And this is the Z-score, okay? Now let's draw this again. What if I cut this in half? Zeros here. So this will be 50% here, 50% here, right? Let's draw it again. So this is 0, and we know that this is, half of this is 50%. What if I drew it around 1? Would you say this is about, I don't know, 75% and maybe 25%? Something like that, right? We can eyeball it and we can see that this, if this is 50%, then this area has to be greater than 50%. Alright, so let's go back to our proportion or probability. So it asks, what's the probability of getting a Z-score greater than 0.25? For that, we have to look at our distribution table, okay? So here we're going to look for, and this is on page 584 of your book. So we're going to go to Z-score here. We see column A, we look for the Z-score in column A. So I find it, and the Z-score is 0.25 here. Column B tells us the proportion in the body. So the body is the bigger portion of the normal curve. And then column C tells us the proportion in the tail. And then column D tells us the proportion between the mean and the Z-score. So basically, the mean is always 0. So from the center to the Z-score, okay? And you'll notice that columns B and C will always equal 100%. Alright, so here it asks, what's the proportion of getting a Z-score greater than 0.25? So if we drew our normal curve, 0's here, so 0.25, if 1 was here, 0.25 would be a quarter way here, right? 0.25. Sorry, it's a little hard to see, but so automatically we know that it's a little bit to the right side of 50%. But it says, what's the probability of getting Z greater than 0.25? So we're interested in everything this way, right? So we want to know this portion here. So if this is greater than 50%, so let's say this is 55%, I'm just estimating here, 55%. I'll put a question mark. So we know that this has to be less than 50%. So let's look at our unit normal table, and it tells us for a Z-score of 0.25, the proportion in the tail, so if this is the body, since it's the bigger portion, this is our tail, so we are interested in column C. Column C. It gives us 0.4013. And that's our answer. So, to write it out, P of Z greater than 0.25 equals 0.4013. You may notice that there's no 0 here, but there's a 0 here. Why is that? Because whenever in behavioral science like psychology and sociology, whenever a number can be greater than 1, the zero is included when there's a decimal. Okay? But when the number can never be greater than 1, there's no zero. So proportion can never be greater than 1. The highest number you can get is 1, right? 1 equals 100%. And 0.4013 equals 40.13%. Just an FYI. Okay, let's try another example. So let's try a little bit harder. It says, what is the probability of getting a z-score, let's do less than 1.20. So first I draw my normal curve. 0 is here. So let's say 1.20 is right here. Okay. So it wants to know what's the probability of getting a z-score less than 1.20. So we're interested in everything this way. Anything less than 1.20. So we're interested in this area. So if half this curve is 50%, we know that this body is going to be greater than 50%. So I'm going to estimate that it's 75%. Let's see what our table says. So we go back to our table here. Sorry, it's probably... So let's go column A. We're going to look for 0.7 or 1.20. Okay, and that's on page 585. Let's go 1.20. Proportion in the body is 0.8849. Proportion in the tail is 0.1151. So we're interested in the body, the bigger portion. This is the body. This is the tail. The tail is always the smaller portion. Okay? So 1.20, it tells us a number of 0.8849. So our answer is, if we write it out, z less than 1.20 equals 0.8849. And that's exactly how you write it. And this is how you read it. You say the proportion of getting a z-score less than 1.20 equals, I'm sorry, the probability of getting a z-score less than 1.20 equals 0.8849. Okay, so let's go to middle scores, which is a little more confusing. Okay, so this question asks, what is the probability of getting the middle, or this is exactly how it's written, the middle 50% from 50% in the tails. So it says, what's the probability of getting 50% from 50% in the tails? It's a little weird, to be quite honest, but this is what it's asking. Okay, so let's say our middle portion is 50%. Okay, so we know that we have 50% left in the other two sections. So these two sections together equal 50%. Okay, so let's divide the two sections equally. So we know 50%, or 50 over 2 equals 25. So we know that this portion is 25, this portion is 25. Okay, and the question asks, find the z-score boundaries that separate a normal distribution as described in each of the following. So find the z-score boundaries that separate 50% from 50% in the tails. So basically, we want to know the z-score for this portion and z-score for this portion. We know the middle is 0. Okay, so let's find our boundaries. So we're going to go back here. Now we're going to look for a proportion in the tail. Okay, so we're going to find in column C 0.25, or the closest number to 0.25. So the closest number I see, let's look at column C, and I'm on page 585. I see 0.2514, and I also see 0.2483. So now, you want the proportion that makes this body larger, okay? So basically, I'm going to choose this one because 2514 makes this portion, wait, I'm sorry, hold on. Scratch that. Okay, so 0.2483, 0.2514. Yes, so I want the z-score that makes this portion the smallest. So the z-score corresponding to 2483 is 0.68, and the z-score corresponding to 2514 is 0.67. So I want the one that goes further out because it makes you guys will cover that in hypothesis testing. Okay, so I want to get 0.68. So basically this is 0.68 and this is negative 0.68 because it's identical. Okay, so again the answer to this is 0.68 here and negative 0.68 here. Let's try another one. So this one asks, find the z-score boundaries that separate a normal distribution as described in each of the following, which is the middle 95% from 5% in the tails. So I'm going to draw my curve again. Always draw your curves when you're stuck. It helps me every time until you're able to do it in your head. Okay, so we know the middle portion is 95%, right? The middle 95%. So that means we have 5% left over, right? And we have to separate the 5% from the two tails. Okay, so 5 over 2 equals 2.5. So we know this is 2.5%, 2.5%. So now 2.5 over 100 equals 0.025. Okay, now we have to find here in column C 0.025. And let's see, go to 0.025. Alright, we find exactly that actually. Column C on page 586. If you go to 0.025 in column A, you'll see that the z-score associated to this is 1.96. 1.96. Okay, so this is 0, this is 1.96, negative 1.96. So another way to write this, if I were to write this, I can write something like the P of Z greater than 1.96 equals 0.025. Okay? Or P of Z less than 1.96 equals 0.025. Yep. Okay, so let's try another one. Let's do another example. So last one asks, this is number 4 in your guys' worksheet. The worksheet was given in class. The distribution of scores on the SAT is approximately normal with a mean of 500. So we know the mean was 500, okay? And a standard deviation of 100. So standard deviation equals 100 for the population of students who have taken the SATs. So we know we're working with populations because it said it in the word problem, okay? The first question asks, what proportion have SAT scores greater than 700? Okay, so let's draw this out. So the problem said the SAT scores are about normal, so we can draw a normal curve. Okay, the mean is 500. Now, keep in mind we're working with X now, okay? Because they said scores, which is X. So 700 is, let's say this is 600. Say this is 700. Okay? Now they want to know what's the probability of X being greater than 700. So you might think that first thing we should do is jump to our tables, right? But you can't. We have to convert this to Z-score first, because the tables are Z-scores only. It'd be impossible to put all the different scores for SATs and stuff like that. You'd have a gigantic book. It wouldn't make any sense. So the formula for Z-score equals X minus mu over standard deviation. So let's plug in our knowns. 700 minus 500, our mean, over standard deviation. Right, 200 over 100 equals 2. So let's rewrite this now. What's the probability of getting X greater, what's the probability of getting a Z greater than 2? So we know that Z, 0, 1, 2. So what's the probability of this? What's this portion equal here? So we know that this is the body, right? This is huge. And this is the tail because it's smaller. And let's go to Z-score of 2. So let's go to our chart, our table, and look in column A for a Z-score of 2. And automatically we see in column C, the answer is 0.0228. Okay? So we know that this portion equals 2.28%. In other words, if you get a score of 700 or better on your SATs, you are in the 2 percentile of the population of people that took the SATs. That means you are better, you did better than roughly 98% of the people that took the SATs. Okay? That's all that means. So let's try another one. Alright. So it asks, what proportion have SAT scores greater than 500? In other words, what's the probability of getting X greater than 550? Right? And you know that in order to work with this, in order to find the answer, we have to convert this X score to a Z score. So I always write my formula first. Z equals X minus mu over standard deviation. Plug in your known values. 550 minus the mu was 500 over 100. Alright, so 50 over 100 equals 5 over 10 equals 1/2. Okay? Or 0.5. Okay. So it's important to know that in stats we don't use halves. So make sure you convert everything to decimals, or you'll be marked off like I was. Okay. So back to our table. Let's look for proportion. So let's draw this real quick so you can see what we're trying to find here. This is 500. We're looking for 550. We're seeing what's this proportion here. Okay? In other words, so this is for X, this is for Z, this is 0, we're looking for 0.5. Okay? What's the proportion greater than 0.5 for Z-score? Let's go to our table. We're going to go to Z equal, in column A, Z 4.5. Here it is. So Z is 0.5 here. The proportion in the tail equals, so this portion equals, if you look in column C, 0.3085. Okay, so if we wrote this, it would be P of x greater than 550 equals 0.3085, or same thing. Okay? Alright, last one. Or do two more, might as well. Now the question asks, what is the minimum SAT score needed to be in the highest 10% of the population? Okay, so let's write this out. It asks, let's draw our unit or our normal curve. So it wants to know this 10%. What SAT score do I need to be in the highest 10% of the population? Okay? How am I going to do that? So this is, so 10% is 0.10, right? So we know that the proportion is 0.10. So if we go to our table and go to column C and look for 0.10, let's look for 0.10, I find 0.1003. That corresponds to a z-score of 1.28. So 1.28 is right here. Okay? But that's our z-score. So now we have to convert our z-score back to an x-score. Because the question asks, what is the minimum SAT score needed to be in the highest 10% of the population? Not, what's the z-score needed to be in the 10% of the highest population? The z-scores don't really make sense. It just tells you where you are relative to everything else. So let's convert this back to z-score. We know that z equals x minus mu over standard deviation. Let's plug in our known values. So 1.28 equals x, we don't know x yet, minus 500, and the standard deviation is 100. Okay, so we're going to multiply both sides by 100. Here, get to use my red pen. These cancel out, right? Now these move 2 decimal places, 1, 2, because 100. 128 equals x minus 500. 128 plus 500 on both sides, right? 500 here. So these cancel out. Equals x. So 628 equals x. So the question asks, what is the minimum SAT score needed to be in the highest 10% of the population? Here, we did all this math, and we found that in order to be in the highest 10% of the population, I need to get a SAT score of at least 628. Okay? The last question asks, if the state college only accepts students from the top 60% of the SAT distribution, what is the minimum SAT score needed to be accepted? So this is basically the same thing, we're just using different numbers, okay? So it asks, if this was the middle, 500, and let's say this is 60% here, about there. So what is that number? If I were applying to a school and they say I need to be in the top 60%, what score do I need in order to be in that bracket? Okay? So we know this proportion is 0.60. So let's go back to our table and look at column C. Since this is a tail, okay, let's look for column C, 0.60. Where would that be? I'm sorry. We're gonna move it here. It's actually the body. I'm sorry. All right, 6.60 because it's bigger. So this portion is 40. So this is actually tail. So we're gonna look for portion in the body. 0.60 in the body. Sorry about that. Okay. So now we're looking at column B. Since we're looking at proportion in the body. Closest number I found is 0.6026. So 0.6026 is the closest I found. Alright. And that corresponds to a z-score of 0.26. 0.26. Does it make sense? So actually it's a negative 0.26 here, right? Because it's a little bit left. We know that if, let's see, yeah, we know that 50% is here, right? And this is 0. And we know that 60% by definition has to be a little bit left of it. So this is negative 0.26. So this is a little tricky. So in order to find the z-score associated with negative 0.26, we have to convert it to an x-score. Okay? So we know that z equals x minus mu over standard deviation. Okay? 0.26, negative 0.26 equals x minus 500 over 100. Okay? Multiply both sides by 100. Move this 2 decimal places, so this is going to be 26, right? So 26, let me see, hold on, sorry. Having a brain fart. Yeah, 26 equals x minus 500. We add 500 to both sides, so 500 negative 26. 500 minus 26 equals x. So 500 minus 26 is 474 was x. So I have to get a score of 474 in order to get into the school, which is not too bad. So I can get a little bit below average and still be accepted in this school. And that's it. If you have any questions, just leave a comment and I'll do my best to answer. Thanks.